Hello everybody and welcome to my stream. My name is The Perfect Argent and here we talk and see mostly about code development in Rust. So, well, I'm back from holidays, so this stream is going to be probably quite scuffed, so sorry in advance for that. News. So this is the first time I'm trying to record a stream. Let's see if it works. If it works, I promise I'm going to upload it in YouTube. That being said, I have not set up the YouTube channel yet. The channel name is reserved, so it's going to be also Perfect Argent. But I have not set up the channel at all. I will do that while I am uploading this stream. So that's the first change. Continue with the changes. Yes, there is another thing that I didn't know because I'm a professional streamer, and it is the fact that I could enable things for followers, and I have done that just now. I don't know how it works. I think that bits and I think that at least channel points are enabled, but I just figured it out 1 hour ago, so I have not taken a lot of what to do with those, but I think I have enabled them, so you can start how it is called. You can start accumulating points. Bits, I don't know anything about her, so I don't know. They're there. I will read about it. And the other thing that I did, I have not set up any emotes because I am not an artist. This is still just a hobby channel, so I'm not yet in a moment in which I can afford to pay actual artist to make some emotes for me, but at least as a token of appreciation for being a follower, you have access to these three, which are stock, I know, but it is what we have at least at the moment. What else? A new change, and I am quite hyped for it. So you may remember from the streams that we had back in the day, those were not recorded, so they are the lost era. So you're new to this stream, you know what I'm talking about. So here at the top right, I used to have a small box telling what is what we're doing. And this is not updated. This is just showing my test, but I think we're going to work with this. We're going to work on this project today, and then the box had a series of steps and things that we want to do, etc. It was just text only. I mean, it worked. But it wasn't the prettiest, and it wasn't linked to anything realistic. So instead of that, I have taken the opportunity, thanks to Goldberg, to change things a little. So first of all, what is Goldberg? Goldberg is a place where you have your Git repos. So like GitHub, like GitLab. The main difference is that Goldberg, as you can see, is .org. Is a non-profit organization based in Germany, so here in Europe. and I am seeing many people moving here, and I quite like it, so much so that I plan to donate. I'm going to do a donation by myself, and obviously if I manage to monetize Twitch or YouTube, I will try to keep those donations going, because I think it is a nice project to be able to host your Git project in a non-profit, especially when the for-profit companies doing so. It's okay that they link to AI. However, some of the ways that they are using AI or using your code for their AI, I may have some issues with those. So I decided, let's give this a chance. So here in Codeberg, I have an organization called Digital Labs. Of course, I have my own user already there. And here we can host projects. So the first thing that we're going to do today is to actually create a project for a compression crate that we're going to create, that is going to have, again, for the moment, LZ77, like what we did in the quote-unquote lost era, in those streams that are now lost in time. And we are going to use the project tab the projects tab of the repository that has this dashboard to keep track of the things that we want to do with that project. So once again, back in the day, we were I was just writing things around. How does that work now? Well, I need to go to issues, because as far as I know, the only type of cards that you can add to the dashboard is based on issues. So we go to issues and we create a new issue that can be a feature, like having the full LZ77 compressor. In this case, I just created one that has more narrow focus, which is just a mock encoder for LZ77. We'll talk about how we're going to approach this compression project later. But basically, we create an issue, and that issue is linked to a project which I have called dashboard, just because then when I go to project dashboard, this is called dashboard. No surprise. So yes, this could be called the name of the project, but at least at the moment, let's keep it simple. If you have any names or a nice name for a compression project that is just for educational purposes, we're not going to create the most terrific compressor ever. There are good reasons for that, and I will talk more about compression. Believe me, I like compression a lot, so I will talk about compression over and over and over. So once we have these cards, the idea is that we move them. Backlog, meaning this just things that we may or may not do, to do things that we're actually trying to we have moved from the backlog because they need to be done. In progress, this will be one of the card. The card that is going to be shown here is basically one card from the in progress column, and obviously when it is done, I will move it to done. uh, because the card is related to an issue, and that issue of course is going to at the end be related to a pull request. Everything is basically going to be nicely wrapped up. A card is closed with an issue is closed when we have a pull request with that. Pull request is also a new thing that we're going to work with. So once again, when we compare what we're going to do with how I did things in that lost era, I basically was just programming in old style and just writing some code, pushing that code into commits with no rhyme or reason, no order, etc. And that works quite nicely for personal projects. One moment, because I think there is a bit of echo. Okay, so I think the echo is because I had the mic too high. I think you can still hear me well, but there is a little bit less of echo now, or at least I hear less echo. We will see later in the recording. Anyways, so as I was saying, I was using Git. I was developing in a very non-professional way, very amateurish way. So I want to start doing things. Anyways, I have been trained to do. I have done from time to time, which is basically by driving the development of code through pull requests. So what are those? Basically, a pull request is when a developer requests that the project pulls a change that a series of changes, a series of commits, typically in a branch. And that's a typical pull request. One thing that I like is to, or an idea that I like is to link an issue to a pull request. I have actually not taken a look at how to do that, because we can try, because this is a test project. So if yeah, forgot about that. There's no way to create a new pull request because we don't have any branch. First, we will need to create a branch. Okay. So I will probably learn how to do this correctly. Basically, branch for the issue. Let's see if it works like this. Doesn't. Okay. So what is... How do I create a new... Here. Yes. This is branches. Hello. How can you run? I'm new to this. I was used to GitHub. So, see, bear branch. Cool, doesn't say how to do that. Okay, so I know how to do that locally. I'll push to create feature is disabled. That's a good thing to know because I was going to try that in a minute. Need plugin. So issue tracker. No. Okay. So pull requests. Right. So as you can see, the idea behind pull requests is to have a workflow. So basically, as you can see, a pull request collects the full edit history for a fix or a feature branch. So it is using. Okay, yeah, we're going to clone it. And says now let's create a feature branch. Okay, yeah, so here it is creating that branch. I wasn't aware that you could do that with a checkout. So you have some commit, you have the branch. Yes, you may need to base. At the moment, we're not going to have issues with owner rights because as far as I know, I have removed permissions. We will see if I did it correctly or not. So what happens is that, okay, no. That there is no link between the name of the branch and the issue with the pull request. And this is something that I didn't know. I know that you could do in GitHub, didn't know how to do, but I know that that existed. Anyways, so the idea is the way how we're going to work with a project. So we're going to create a project, and we're going to create a project in a few minutes, because again, this is something that I have done to test some of the features of Codeberg. Then we're going to do something like this. So we're going to create a dashboard project, and we're going to create an issue, a few issues. So one issue, for example, for the full LC77 class compression, and then a new one which is going to be the mock encoder, and then we're going to go to our local machine. We're going to create the branch like this, and we're going to create that mock encoder, and when that mock encoder is finished, then we will create a pull request for that branch. In the request message, I will link to the issue URL, and see how it works, and then I will read later or tomorrow if there is a smoother way. Let's try Goldberg link request to issue. So you see, this is something that in GitHub is done. So we are not using that. So as you can see, is by using a supported keyword in the pull request description or in a commit with one of these. Now, something that we need to mention is why these words, because people can write the comments in whichever way they want, which is also what I will do. But as much as I can, I'm going to try to stick to kind of conventional commits, which is a specification so that commits have kind of some structure in how it is written. So as you can see, that would be fix this, right, etc. So we could do a fix and then say this there. So just with the issue number. So that is what we're going to do. Okay, even if Goldberg is not GitHub and it may not implement it, if it's not implemented, which apparently is not implemented, at least let's take some inspiration from how it is done in GitHub, because again, I think it's a nice thing to do. So that out of the way, what are we going to do today? We're going to work with LZ77 again. So very sorry if you followed me in my last era, you know that that was the last project we did before I went on holidays. We're going to write it again, but not line by line. We're going to use again a different approach to write code instead of being the bottom-up approach that I used before. Basically, I knew the algorithm, I write the algorithm, and then I write all the infrastructure code until I have a compressor working. We're going to use a pull request based workflow with obviously with an issue tracker. I think this is called it's not test driven approach or an issue driven approach. So you only work on things on a project based on, firstly, there has to be an issue open that describes what we want to achieve. So let's do that, shall we? So first of all, as I briefly mentioned before, Goldberg doesn't allow you just to create a project just by pushing changes to a repository it doesn't exist yet. So instead we need to create a repository. So repository. So what is going to be the name? So the thing about the repository names is that they can become the crate names in Rust. Not always, but it makes it more easy if they have the same names. So yes, I'm going to still use my prefix with the underscore, which is the separator that is used in crate names, and then expression. Okay. No, the repo is not going to be private. So if you connect to the repo, you can see the code. You can fork the project, etc. if you so wish, because once again, this is educational code. So I don't think I'm going to be too picky if even an AI scraps the code, much less if you do it. Short description. Educational code required classical version data algorithm. Use template. Templates are very, very useful. That being said, I don't have a template like here. How to do the template? I could create a repository, mark it as a template, that would work. But at the moment, I have not done that, so there is not a template. And while I don't have a template, I can't do. So what I did instead, because again, I wasn't using Codebird, is that in my project directory, I have a skeleton. Right, as you can see, the initialize repository, which is kind of a skeleton by itself, it says, yes, have a README, we have a README, optionally a license. In this case, I do have a license. Git ignore files. I have a git ignore for Rust. This is actually taken from one of the test projects in which I used a Rust repository, sorry, a Rust initialization. I'm using Kate instead of an IDE as an editor, code editor. So I have added that, and I have a cargo toml for cargo. Now, this is not the best thing to do, because this is not how we create a project in Rust, obviously, right? So basically, in any case, we don't need to initialize the repository because we're going to have all the data there. So just let me double check. Don't need to change anything of the advanced settings. Create repo. All right, and it is empty. So it is telling you, hey, sorry, there is this, but it's absolutely empty. By the way, we're not using HTTPS, we're using SSH. Why? Because I have already set up my user account to have an SSH key in code here in Codebird, and also enable commit signatures with the same key, by the way. So the advantage of that is that all my commits are linked with my profile that show the icon. Right, let me show you. Go to here, commits. So you can see this one that I did wrongly because I didn't I hadn't configured the SSH key correctly, but now you see everything works fine. So I actually recommend you to do that, to set up SSH keys. That works in GitHub, in GitLab, in Codeberg. Use an SSH key and use the SSH protocol instead of HTTPS to send the commits, etc. As for the fact of signing the commits, you can do that with an SSH key or a GPG key. For the moment, I'm keeping it simple. I'm just using the SSH key. All right, so now we have this project. So how do we work with locally? So as you can see, first we need to create a repository in the command line. So in this case, Data Compression as a project should evolve into a workspace with multiple crates, with multiple libraries, probably, and maybe even binary crates. For the moment, the basic thing is the library. Instead of what we did again in my last era, in which I used a binary crate, here we're going to work with, okay, what are we doing? We're going to implement compression algorithms. Those compression algorithms could be used elsewhere, so it makes sense that this crate is initialized as a library. And obviously we're going to give it the same name. So as you can see, now instead of having a README, we have a Git with a git ignore, with a cargo toml, and an src directory that just contains a test librs. That mainly works. However, remember what I have prepared in the past, my skeleton. So this skeleton now, if I copy it, it will overwrite the git ignore and the cargo toml, and that is correct. Why? The git ignore here is just target, right? And as I said before, the git ignore that I had in skeleton directory is actually I think taken from a repository that has git ignores for many languages, and this is the one that it has for Rust. So it adds more things, which probably we're not going to use, but I think it makes more sense to have something more complete. And again, this is just a shortened version of a typical that is used, for example, in GitHub for Rust projects. What about the cargo toml? The cargo toml is just the name, the version, and the edition. However, the one that I have in the skeleton, yes, it has the Chrome project name, that is a given. It has the version, it has edition, but then it has more things. So it makes more sense to have things here. All right, so now we have the skeleton of the project. This moment, I think it is due time that we launch our trusty editor, Kate, and go there. So what do we need to change? Git ignore, again, it is absolutely correct. Kate project, however, it's not, because the project name is wrong. So why do we need a Kate project? This allows later, when this is when I close and reopen Kate, to have a specific cargo build, cargo clean, cargo format options in here in the build menu. This cargo lock, I don't know why it is there. It wasn't. So continue with it should be, sorry, it should be created with the correct name of the package. And now that we're here, we can change the project description. We can, for example, make it match the description of the project here. The repository, we're not going to have it yet. The repository entry in Cargo Toml is useful when you're going to publish the crate. We're not going to do that yet, so I'm going to keep it commented out, but at least we're going to give it the correct link. License. So I kind of strange about licenses. Let me show you. So the Goldberg documentation has this very, very useful page, and it gives you a simplified decision diagram for choosing a license, and basically you end up with the AGPL, the GPL, the Apache, or the MIT license. So use one of four. The reason, and I absolutely understand it, is license proliferation. Okay, if you go to the, I think okay, so you see, choose a license has a problem because it's created by GitHub, and if you go to FOSS, I think, I don't remember the name of the website or the organization that is managing open source licenses, they have a lot. So license proliferation is a problem because it makes, I agree with them, with Goldberg here, it makes it more difficult for everybody to understand the meaning and compatibility. That being said, me personally, I make an exception for the license that I'm using, which is the EUPL. So what is the EUPL? The EUPL is European Union Public License. So this license is created by the European Union itself as a supranational government body. It is translated into the official languages of the European Union. So with that, it makes it more difficult for everybody to understand. Well, if it is written in your language, it may be more easy to understand for more users, not just developers. And also, in some countries, they have put the UPL kind of inside their regulations, meaning that in theory, if there are some issues related to copyright, etc., judges should know about the UPL or what it entails. And the second exception, right? So the compatibility between them, the UPL has excuse me. Oh dear, I'm going to try to talk for a little bit. Okay, I think it's better. So as I was saying, the UPL has an official list of compatible licenses. So because it has integrated compatibility list, and in my opinion makes it easier for everybody, developers, to understand, because it has officially approved translations, and because I'm European, that's the license that I'm going to use for the majority of my projects. If you don't care about that, or you are not in the EU, and you want to use other license, then I do highly recommend you to once again go to Goldberg, the documentation, and follow the simplified decision diagram. Okay, simple as that. So I don't see anything wrong with using any of these four for your projects, but again, for my projects and for the reasons I have established, I'm going to use the EUPL. So that's my license. The license is set up here. It is obviously copied as a file. One thing is kind of important. One thing that I like about both GitHub and GitLab is that they have the licenses already uploaded, and in your projects, your repositories, you can choose a license and it will be copied from there. So it also shows the license that is applied in the sidebar of the project, of the repository. So I think it's a nice feature. However, it's not needed, right? It's just something that it's a nice to have. So yes, a minor point against Codeberg, but again, it's very minor. Again, I already have the license here, so README. So let's quickly change the README. It's going to be expression. We're going to copy description. Next record. And yes, over time we will be completing this, especially description and background. Authors and acknowledgement is already okay. Project is done by me with your help, and pointing to the license file. So this is okay. Now, because this is, I don't own this code that is written by Cargo, I'm not going to add here any copyright notice. I'm just keeping it as the authors of Rust and Cargo have done, no license. But in general, you will see that one thing that I consistently did and will continue to do is that every source file we have a license node using SPDX headers. But basically, this is a nice start for our project. So now, that is would be basically the equivalent for this and this, and also this. Why? Because if I go to branch, well, sorry, the default branch is main, so that's not going to be a problem even if at the moment it doesn't show here. So we have the README. So now we're going to add the commit. Now another thing that we're going to do is to sign off commits. So signing off the commits is not the same as signing the commits. Signing the commits means that the commits have a cryptographic proof. In my case, through an SSH key, that I am the one authoring that commit. Signing off the commit, let me show you. Commit. Signing off means that there will be sign off by trailer at the end of the commit log that is added automatically. I don't need to do that for this project and for many projects because I am the only one committing, right? But when there is a project that is community driven, when you can have multiple developers, etc., there has been issues in the past with the licenses and different developers. The more classically one is when the project wants to change or to pivot to another license. If you have many authors, then all of them will need to agree in the change of the license. That is that's a big headache in some project, but there can be other things about that. So with reuse, which again we're not going to dive in today, applying licenses and applying signs off, we can keep track of not only the authors of different portions of the code, but also that they have agreed to some as you can see, they may certify that the committer has the rights to submit the work under the project's license in whichever way you want to do, meaning that I could create, for example, reuse rule that says you are agreed that I am the one calling the shots on the license for as long as the license is compatible with the UPL, for example, right? And that means that when you sign off a commit, you agree with that. Obviously, I don't need to agree with the rules that I have not even established yet. I'm always going to do, but I think is a good thing to be prepared for. Now, Git will not have a configuration variable to enable sign off by default, meaning that if you want to sign off, you have to and you will have to add sign off every single time. Obviously, that is an easy thing to do. Is here the git commit becomes minus s for the sign off, and then minus m initial commit. Oh, sorry. Nothing I had to commit. Okay, yeah. So good catch, Git. Yes, I forgot to add things. Let's check on the cargo log first. Yes, it has now the correct name, so we can add it. So now we have git ignore git project, the cargo license, readme, and that. So now that is perfectly okay. So now let's try again to commit, and we have creating a local commit, for that. Now the next thing to do is to add there as a remote the remote repository of the repository, the remote collection of the repository, the one in Codeberg. And now this would push things to Codeberg. All right. Now it is actually saying that I have the main branch, correct? So how does that work? Now, if I refresh target compression, now you can see that I have one commit, which is that initial commit that is wrong. What happens? It's not a sign. It is not signed. Well, you can see the signing off, it is okay. Oh, yeah, I know what it is not signed off. So let me show you. So I'm going to open my terminal. So the reason this doesn't work this is so I want to be fancy, so I'm going to get the project and actually going to delete the project and to recreate the project. Can I delete the comment? Yes, I can revert. Revert initial commit, nothing, commit directly to main, new branch, changes. No, I know what is this going to do. It's another commit. I don't want to do that. I want to completely eliminate commit. I don't want to exist anymore. And I can do that. So yes, I want to do things in a very fancy way. But now I understand why my first and this, by the way, same thing happened to me here. This compression. I go to commits. You can see the first commit wasn't correctly signed. The reason for that, let me show you after I delete the Dargen repo, so we can recreate it. So settings, standard zone, delete the delete everything, enter the owner, everything exactly, yes, web tab. Now if we do this, it does disappear. All right, so what is happening? So let me show you. So my configuration, I think I can show it on the screen, just in case. Not really. So at least in Linux, right, there is a git config file that is basically the global configuration for Git. You can have also configuration for your individual repositories, but this is the global one. In this one, in this file, I have things that I can show you, that I can show. So for example, that's why I knew that I didn't need to create the main branch and it was going to work because the default branch by default is main. Now, why do we have this? Back in the day when Git was created, the default branch was called master. There are people that didn't like that name for whichever reasons. We're not going to delve on that. And that means that many projects have a different default branch. However, depending on the version of Git, the default branch can be either master or main. By adding this, you ensure that main is indeed the default branch, irrespective of the version of Git you are using. Then, other thing that I have done is this. So basically, I'm saying that if the configuration for a project has a remote in which I'm using SSH Codeberg :user -project, that will then I'm going to add more configuration for those repositories. Now, one thing that if you have a lot of luck is that you realize then when I added the remote, here is code is codeberg.org/user, not :user. That's because in Codeberg, this notation works for repositories that are attached directly to a user. However, the repositories that we're using are tied to the Dargen Labs organization. So if you're like me and you're using organization and you don't find out why your signatures don't work, it's because you need to add a different recipe. Both can direct to the same configuration, but the inclusive has to be different. It's codeberg.org/user. In this case, the user being the organization. Okay, So once you have that, then obviously what it is here. So once again, let me see if I can show it on screen. Yes, I can. So that file says, okay, we're going to sign the commits, meaning they have this cryptographic signature. This is not the signing off, and they're going to be signed. Now, the way that is done in Git configuration is with GPG sign. So you also now need to say, hey, and by the way, by GPG, I mean it's actually an SSH key, and the signing key is here. Okay, this is an SSH key that I created both to connect through the SSH protocol of Codebird, and also in this case to sign. And the email address that Codebird has provided to me. This is very important if you are starting using Codebird or GitHub or GitLab or Git or whichever system. Your commits always have your name and your email address, right? The username, I changed that in the global configuration. As for the email, by default is your email. So because those are going to appear in commits in public repos, you are sharing that email address with everybody in the internet. That can be okay. Don't get me wrong, that can be okay in some occasions. But most likely than not, that's not what you want to do. So those Git hosting systems, okay, can be GitLab, GitHub, or in this case, Codebird, they provide you with email aliases. So basically, if someone emails here, the email is going to come to you, to your real email, don't get me wrong, right? So you can still receive some spam. But it has the advantage that they don't have your email. So they can add it to spam list, etc. Meaning that if later you stop using Codebird or you stop GitHub, etc., these alias, these email alias will no longer work, and your email will remain private has been private all the time. So this is a good thing to do. And because once again, this is the email address that is going to be shown, I'm okay showing it on screen. All right, so this is signing key. So that means that my commits are signed. However, the one commit that I did wasn't signed. Why is that? Because this only triggers when the remote has already been configured. And here, I added the remote after the commit. That's the problem, right? So let's do this once again. So I'm going to read this. I'm going to do cargo in endlessly Dargent compression. I'm going to close Kate. I'm going to reopen it. So I have kept everything here, everything here, everything here, and here. Cool, cool, cool. So now we have these files. Next thing to do, we need to recreate the project here in Codeberg. So repo name, same as the package, description, package, no template, no initialization, repo. And now what we need to do is to reverse the order of these two maths. So let's go to indulgent compression. And now once again, what we need to do is first add the remote. Why? Because now, if I go to git config, you see that now I have a remote with a URL that is going to be caught up by the rule that we had in already established in the global git config. Then this needs to be signed off. And that means that now when I do git commit, sorry, I don't do a git commit. First I add everything. Right. So now when I do the git commit, this commit should be signed. So I know that it has been signed off because it has the email address, correct one. So this has been signed off correctly. Let's try that again and push it. All right. So let's see if correct. Project, and now you can see that the commit. Well, it says that no known key is found in the database, which is not right because I put that key in the configuration. But at least there is a key. That's important. The fact that there is a key is important because I can because I'm using a public key. So I can add. So this I could show on Stream Center. I can fix this, but at least it is signed and it is identifiable. This has been me. Initial commit. So now we have the skeleton of the repository. What's the next thing that we're going to do? That's important because that gave me some headaches the other day. We need to go to settings. We need to go to units, overview, and projects enable repository projects. That is the dashboard, right? So again, you don't need to do this for every single project, but if you want to have those integrated Kanban dashboards, you need to have this. Save, and now you can see that I have projects. I'm going to add a project that, once again, for the moment, just going to call dashboard. Based in Kanban, that means the 4 columns that I showed before. And I create a project, so I have the dashboard. Now I go to issue, and I'm going to create a new issue that is going to be to implement LZ77 like a compression. Okay, no branch, no tag, because this is going to go to main one. For labels, this is a feature. No milestone. We're not going to use milestones for the moment. Projects, yes. Yes, and thank you. Dashboard, and yes, it should be assigned to me. Create the issue. All right. So as you can see, it has been added to the dashboard. So now if I go to the project dashboard, you can see here that is in the backlog. And of course, this is what we're going to do. I'm going to move it to the to-do column. The next thing that I'm going to do is I'm going to take a screenshot card. And I'm going to save it in a file that I have already created. And let me see if OBS has yes, it has updated the card. As you can see them now here at the top right, the card is implement LZ77 like compression instead of the card that I had before, which was to implement the LZ77 mock encoder. That being said, that's actually the first thing that we're going to do. So we're going to create an issue regarding that. Implement encoder for compression. So once again, this is a feature. What else? Priorities, reviews, status. That's all. Well, good. We're going to dashboard, assign it to me, create the issue, and now go to project dashboards. Now we're going to move this card not to do, because that's actually what we're going to do today. So I'm going to put it here in progress, and because that's actually the one that we're going to have in progress, that's the card I want to do. And yes, I was checking that it has been updated here. Cool. So now you can see that's we have kind of a workflow for all of our streams, which is going to be working on repo using the issue tracker and the dashboard project to keep track of different cards. I will put here at the top right what is the current project, more or less. As you can see, it's just overarching theme, not exactly the name of the project. And then the current card that we have in progress and actively working on stream. We can imagine that we may have multiple cards in progress, but obviously we're only writing code for one card at a time. So that's what we have there. So let me clean this up. Now we have this, and that means that we are now ready to write some code. More specifically, this is going to be implemented in the library. That being said, I have been streaming for 1 hour, 15 minutes, something like that. So, in case you don't know, we have the oops, words fail me. Just give me a second, chat. We have the custom of having from time to time a stretch pause. Obviously, now in Europe, with this fine weather we are all enjoying, it's going to be extra important to also have some hydration to that stretch. So a quick stretch and hydration pause. We're back in 2. Hope you too. Yeah, see you. I'm going to put some music, by the way. Music. Normally I add music in the background, but today I think it was very important to focus on what we were doing at the beginning, setting up everything. So I removed the music because I have not equalized all the tracks, so some of them are quote unquote louder. You wouldn't believe the amount of tuning down that they have. But they are there. So, that's interesting. I don't hear. I can see in the mixer. Yeah, I really have this way down. Let me change to another track. I think it sounds higher. Yes. Now I can hear some music. So I will leave you with some music. Stretch and hydrate, especially I'm also suffering from current weather. I will see you in 2. And we're back. So once again, I'm going to stop the music. I typically like to have the music in the background. It's copyright free, so I think YouTube shouldn't have any problem. I don't know, however, how the recording works, or if I can have different mixes in YouTube than in Twitch. I still need to learn more about this stream thing. So, okay, so let's start, shall we? So, we have arrived to the conclusion that we are working. The next thing that we're going to do was to work with creating a mock encoder. However, we do that using a pull request. That's the type of workflow that we want to use. Right, so let me open that again. The request. All right, so the cheat sheet is this, which is something that I actually have never done. I typically just create a local branch instead of doing a git checkout minus branch, etc., etc. And let's try. Maybe it doesn't work because the branch doesn't exist. So who knows? So we're going to do git checkout branch. Now, what's the name of the branch? We could, in theory, name the branches after the issues. So the branches could be called issue 1, issue 2, issue 3, etc. Problem with that is, after a while, when you take a look at the code and the commits and the branches, etc., right, you will see just issue 1, issue 2, issue 3, and you don't know what they are, what they mean, what they are for. Here, as you can see, the branch has a name, right? It's about the feature that they want to implement in that pull request. That pull request is actually linked to an issue, at least for our goals. But how do we link this, or yes, this to the name of the branch? Right, we could do something like LZ77 coder, and that would be all. And the advantage of this is that this makes this branch independent of the issue. It is just for a pull request. That allows a same pull request to close multiple issues. You can think, for example, when we finally wrap up the LZ77 part of this crate, we would be closing whichever last functionality we're adding, or bugs, fixes, etc., plus closing issue 1. Right, so I don't think it's a good idea to have as a prefix or as a postfix the issue number. Okay, I think this is not a correct thing to do, so we're just going to call it as a simplified version of what we try to achieve. So you can see we have switched to a new branch that has been created locally. Let's take a look at that. You can see we're now on this branch, not on this one. So the idea is that now the commits that we do, so all the work that we do, happens in this branch. And then when we're happy with that, we push the branch all the commits in that branch, and then we create a pull request that, as you can see, we would be merging the branch, sorry, we will be merging into main the branch that it is still not visible here because it's a local branch, at least at the moment, right? And then we would write more things, and we will add a pull request comment in which we are going to use the trick that we have read from GitHub, meaning that we would add a line saying fix and the issue number, in this case #2, and that would be all. All right, so at the moment we have finished with all the heavy lifting from Git, and now we're just to write some code. But of course, if we're going to actually write our code, the first thing that we need to do, as I said before, is to add our licensing headers. So as you can see, it's a copyright text with the current year, my name, and then I'm using not my real email, but once again my alias that Codeberg is providing, and then the license identifier UPL. All right, so that's the first thing out of the way. Now, what's the next thing that we need to do? We need to create a mock encoder. Why is that? Or what is that? We're going to implement LZ77 compression. So for those who were not here during my last age, LZ77 is a classical data compression algorithm. Is based on a paper by Abraham Lempel and Jacob Sieve. That's why it's called LZ. They created two algorithms, one in 1977 and the other in 78. That's why I call 77, 78. We're going to start with this one. Why? Because it is used, for example, in deflate, which, in case you don't know what deflate is one of the most commonly used algorithms, compression algorithms. Is using zlib, is using gzip, is using png, is using zip, and it is patent free. This is important because LZSS, as I think that for a time, no, this one didn't have any patents. However, for LZ78, which is obviously something that we may want to do, the problem was that it was also used a lot, like a lot. And let's see, there is an entry here. It was used in modern communications. It was used in GIF, which it is called GIF, not GIF. There is a guy who says that he created the format. Even if he did, is graphics, not graphics. Okay, so it's GIF. So the problem is that this was a big kerfuffle with regarding to patents. In theory, they have expires, so we should be able to implement it. But this is a trivial variant, so in my opinion, this is the typical mishandling of patents by the USPO. And once again, we will have that that chat when we implement that, because you will see that actually LZW is just a basic improvement upon the basic LZ78 algorithm, and it was worse than that because well, okay, we'll talk about it when we reach the year 78. At the moment, we are stuck in year 77. We're going to implement something similar to LZSS, okay, which is an improvement of LZ77, but it shares many things. So in LZSS, sorry, how does it work? Let's wrap up and focus. Please allow me to focus. So we're going to work on LZ77. LZ77 is called sliding window compression, which means you have some text and you have a window of text that you have already compressed. Then in the output, you can say go back 4 characters into that that window and copy this amount of characters, right? So when the amount of characters is large enough, writing go back this distance and copy this length amount of characters, it's actually shorter than writing those many characters, especially when you have something like run length encoding. Okay, so the length distance pair is shorter to write than the code. Now, what happens if you don't, or the compressor doesn't find a match in the window? In LZ77, it will just output the character following the match. So if you don't even find a match, what actually output is a length distance pair of 0 and the character. It has another problem. If you have a match, that finishes because the next character cannot be matched. But then when you look at that character and the following ones match another portion of the window, meaning that you have 2 length distance pairs back to back, that cannot be done with LZ77. So LZSS improved on LZ77 by outputting 2 different types of symbols. One saying, okay, there is a chunk of data that is literal. So basically, this is literal, this is the amount of literal bytes that follow, and then this amount of bytes. Or a symbol saying this is a length distance pair. In LZ77, those 2 symbols of how to interpret that the next symbol is one or the other was a 1-bit flag. So if we implement LZSS, we have 2 symbols to encode. right? One for literals and one for length distance pairs, which are a mouthful. So I typically call them either a match or a reference to a match. Okay, so those are the two symbols. There is actually another issue that it doesn't appear here, is what happens at the end of the file. Working with end of files in compression also creates kind of a dilemma. So you don't want to run the compressor to end of file and figure out how to finish it. So how the decompressor knows when to stop compressing and decompressing. So yes, why don't you want that to happen when the decompressor finds the end of file of the compressed file? For two reasons. There are some compressors, zip for example, that can compress multiple files in the same compressed file, so that wouldn't work. Secondly, because it helps you with scenarios in which a file is truncated, right? You are downloading a file from the internet and it is cut short. If you don't have anything special so that the compressor understands that that is the case, it will say, okay, this is what I can decompress. So what are the solutions? There are two solutions to that. The first is that the compressed file contains the original file length. That is used a lot. Why is that? Because, for example, in compressors that can compress multiple files, like zip, you may want to encode file names, directories, structures, permissions, etc. already in kind of a header. So adding the file name in that header doesn't add too much. So to the weight of those headers. So it is done. So in that case, the decompressor is provided with how many bytes it should decompress. Issue solved. The other decompressor, however, that can work in stream mode, like gzip, right, with a redirection. It is not provided with a file, but with bytes that come from standard input. So it cannot know the length because it cannot seek to end file, find the length and then rewind to the beginning. So how do we solve that? The second way to encode end of file is with a literal symbol saying here it is the end of file. So what do we want to do? Because we want to write a library crate, we want to open the option for the user of the crate to use any of those alternatives. So maybe we can encode end of file symbols, maybe we don't, and the compressor, when we write the compressor, needs to be provided with the original file length. That means that we need to prepare for the case of LZSS compressor to need to write into the compressed files either a symbol saying a chunk of data, a symbol saying length distance pair, match reference, or end of file. And there are many ways to do that. Right? In the original algorithm, the length and the distance were just 1 byte each. In PalmDoc, for example, you can see that the length distance pair is encoded as a 2-byte sequence. Here, in another implementation by Electronic Arts for some video games, the length distance pair actually had a variable size that was decoded by the first bits in the of the length distance pair encoding itself, right? And there are definitively use or half map, etc. Meaning that given the same symbols, so this is a chunk of text, this is an header file, this is a reference, there are actually multiple ways to encode it. So it makes sense, at least in my head, to have first a mock encoder. So an encoder that is just going to encode the symbols into a vector of symbols. So then when we're running tests, we can try to compress something and then obtain from this mock encoder a vector of the symbols that we can see if they match what it should have been compressing. It can also help when creating the decompressor, because we can have a mock decoder that decodes from the mock encoder, so we can start compressing without actually needing to add the file input-output system. So for all of the reasons, I think it's a good idea that we start with the mock encoder. That being said, that mock encoder has to do one thing, is to receive from the compressor calls to write a chunk of data, write a length distance pair, write end of file, and keep all of those things in a vector. So another call to the encoder provides that vector so it can be used for tests. Okay, so that's what we want to write. So obviously the first thing that we need to do is to define those symbols. Right, so we're going to have public enumeration. Why public? Because it's going to be using tests, and the test exists in other crates, so it needs to be a public enumeration that we're going to call symbol, and that symbol is either going to be an end of file, it's going to be a reference, so this is the length distance pair. I prefer to call it a reference even better than a match, because match is a reserved word in Rust, and this all in lowercase. So reference is better than having length distance pair, length distance pair. It's shorter to write and it still says the same. And obviously because it's a pair, it's going to be a pair of two things. Now, why am I using usizes? Well, think about it. At the end of the day, we're going to try to find a match in a quote-unquote window. That window is going to be basically a slice of memory. So how do you index a slice? With a usize. If you look at the length of a slice, the result is a usize. So all types are going to be usizes. Now, because these can be in different orders, we're going to also do something new with regards to the lost era. We're going to try to add some documentation comments. All right, so we're not going to do things correctly, which would be to start with comment for the full module, for the full size, because at the moment we're just using div.rs. So we're going to have a comment for the symbol. And here for reference, we are going to document, because this can lead to issues, because both have this, both elements of the tuple have the same type. So length, distance, that is going to be the order. And of course, the last symbol is literal. Now, because we want to be able to use it for tests, this literal actually needs to hold a copy of the bytes that are part of that chunk of literal bytes, so that we can compare later in the future. And that means that it cannot just have a reference for the original byte. It actually holds a copy of that. So the literal is going to have, of course, a vector of those bytes. Okay, so that's the symbol. And then we're going to create the mock encoder. So oops, why am I calling it just encoder and not mock encoder? Because I think it makes sense that later we're going to take these things into a different module that is going to be called mock encoder. So obviously there it doesn't need to add mock all the time. So it's going to be called encoder. It's going to hold a vector of those symbols, right? And remember something that I said a few minutes ago, we need to open the door for the users of the crate to be able to use end of file symbols or not. That makes a slight change in the implementation of a real encoder. So even for a mock encoder, can be a good thing to keep track of those things. So you can substitute your real encoder with a mock encoder and things work. Only that you will not be writing to file but to this vector. All right, and that would be our encoder. Once again, let's add a little bit of documentation. Actually, I'm going to use LSS instead of LZ77 because, as we saw before, in LZ77 you just send a single byte, so you don't have a literal symbol. But everything that is variant of that is a variant of LZSS does. So this is order, and then that this encoder keeps all written symbols in a vector that can be used later for tests. Cool. So let's implement it. Obviously, the first thing that we need to do is a constructor, because the attributes are private. And we cannot derive directly default. We could, don't get me wrong, because bool has false as default. But I want the user to be explicit as to whether or not EO end of file symbols are a possibility. So we're not going to derive a default. So we're going to derive new method class function. All right, and let's document. Now, I am going ahead of myself, but I know what I want to write, so don't worry. The thing is, we could have a single function called write or push, and the user just sends us a reference to a symbol. And that kind of works for this encoder, but it will not work for other encoders. And something that we're going to do tomorrow is to separate the implementation of the encoder into an implementation of this encoder class, an implementation of an encode trait that will be shared with the real encoders, so that this mock encoder can actually be swapped out for a real one without changing any other parts of the code, right? By using a trait. A very usual thing to do in Rust. So because of that, the API needs to be thought of as, okay, when my real encoder needs to encode an end of file, a reference, and a literal, do you want it to receive a literal with a vector, meaning that we need to do a memory allocation in a copy? We don't, right? This can get very silly, very slow to implement in a real encoder. So we want the API to be able to be used with real encoders. So instead of that, the API is going to be one function for each type of symbols. So that will work with encoders that don't provide a symbol enumeration. So public function, right, f, and basically we don't need to do anything else in theory, right? But here is the catch. What if we want to write an end of file? Sorry, forgot this method. What if the user tries to write end of file in an encoder that doesn't use end of file? this should fail. And when we will discuss tomorrow the trade, we're going to overhaul the error management, but for the moment we are not returning any result. We're not going to create an error type. So we cannot return a result. So the best thing that we can do at the moment is to add an assert. So if we need a end of file, this works. If we don't need a end of file and we all create AOF, the code panics at the moment. For the moment, again, this is something that we will address when we have the trait and we add error management. Okay, other than that, we're just going to get the vector and we're going to push an end of file symbol. Okay, easy peasy, lemon squeezy. With more documentations. And now we're going to add a little bit of information about the Y. Multi-file, multi-stream compression. This method may be called to signal the end of each file stream. So it can be called multiple times. And yes, in theory, we will need to add another. We will need to add mechanics method mechanics if call for encoders that don't need EOF. Okay. That's a nice implementation for the so let's continue. And next is going to be the reference. Now here we have some particular scenarios. What if a length is 0? That is invalid. What if distance is 0? That is also invalid because you say I'm copying myself, which I have not been compressed yet, so that the compressor doesn't know. That doesn't work. So this method also needs to sanitize its input, and at the end it's even more complex than that, but at the moment for the mock encoder we're going to keep it at the moment like this. And because once again we don't have a proper error management at the moment, we're just going to add an assert that length is more than 0 and distance is more than 0. Okay, and if that is true, then we're going to push symbol reference with the length. Okay, so you see that this is a nice feature of having documentation, is that now when I hover over, I can see that its list is length distance. All right, so let's document this. Length distance per reference. And directly we're going to have the panics. If any of those fall outside valid range. And lastly, let's write a little block. With a little block being just a reference to a slice. And here once again we need to sanitize the input. Okay, this slice cannot be empty. If that is so, we just push symbol literal and with the literal to back. Okay, this method copies the slice into a new vector that obviously is going to be owned by the symbol as it should. So this equals chunk of literal bytes. And yes, panics. Method panics if length of literal chunk for outside range. So have we finished? Not really. We're missing a very important method here. Which is the one that provides to a tester with the visibility of the writer. So I'm going to put it here on the top because these three are basically they're going to become the basic API for the trait. How do we call it? Get coded data, coded symbols, Oops. To that. And once again, let's document. Returns a reference of the reference to the symbols that have been written so far. Yes, we could make this API more complex. For example, we could have another method to clean the writer, which probably makes sense if we're going to test more complex scenarios, but I don't think that we need it at the moment. So now we have a nice basic mock encoder. Now, why did I keep your code here? Because that is another thing that I want to force myself to do. Also, a good thing is to add some tests, right? And in this case, we can actually add some tests. So, as an example, we're going to have a test for right, EOF works. So we're going to create an encoder. And when it works is because we need end of file, right? This is the way in which we can code this correctly, then it should work. So then we're going to call write-EOF, and then we're going to assert that getting coded symbols, it's too long. And result. The result of the test should be equal to a symbol EOF as a reference to a slice, and this fails for many reasons. So as you can see, the first is that symbol doesn't implement partial equality. So here we come back to the symbol, and we derive partial equality. Because we are also going to use these symbols in asserts, when asserts fails, you need to print out the expected and the other value. I mean that this needs to implement debug. Let me show you. Then it complains about debug, as I was saying. We're going to derive it too. And now this works. What this means is I do now do a cargo test. I have a test that passed. Right. So based on that, we're going to create now a new test. This test should panic. I don't remember exactly. The syntax is something like this. So we're going to test that when we call create EOF with an encoder that doesn't need the file, it panics. Oh, I was correct, it panicked. Okay, so now this works. And obviously we can do something similar for the other two calls. So for write literal, for example, these four fails when I have an empty slice as the input. Other than that, it should work. So if I have a little, so let's test equal one U8, 2 U8, 3 U8, and we write as a literal that, then the result should be a symbol, a literal symbol that contains a vector all right. Perfect. And lastly, for literals, sorry, for references, now for reference we need a lot of methods because there are many ways to, at least at the moment, at least two ways to make it panic. Right, one is when we want to write a reference and the distance is 0. And the other is when the length, sorry, when the length is 0, when the distance is 0. So yeah, this is the problem with testing functions that panic, right? Because each panic possibility has to be embedded into its own method. It can lead to having a lot of methods. While, for example, here in literal works, we could have, for example, added only one U8 and test that the literal only contains a vector with one U8, and so on and so forth. So you can do more things in a single function. But at the moment, we're going to keep it like that, again, because tomorrow we're going to work with other things. By the way, Let me check the weather again. So weather tomorrow and on Sunday is going to be the same or even worse, and it's going to be even worse next week, and I want to have more streams next week. So because of the heat and the fact that I cannot have fans, etc., or noisy ACs while I'm streaming, I've decided to postpone the following streams to later in the day or in the night, depending on your where you live in the world. So starting tomorrow, and at least during the summer, I will probably start the streams 4 hours later. I'm going to update the calendar, the schedule, sorry. I'm going to update the schedule. In fact, let me do that right now. Schedule for tomorrow. Let's say only 3 hours later. So sorry for those in Asia, it's going to be quite late. Probably that's good news from those in the Americas. But yes, this is going to be better for me because the temperatures should start going down during that time. Anyways, that was, I got sidetracked. Let's finish this. Let's implement the last test, write reference when it works. So we write a reference with a 1, 2, another reference with a 3 and 4, and now the result should be a literal 1, 2 follow with 0 literal 3, 4. What's happening? Oh yes, because it's a literal. Easy. All right. So let's test. All the tests passed. So what have we achieved today in this stream? We have started with a new workflow in which we're using issues. In our case, we're using Codebear to host the Git repositories, and we're using their issue trackers. We're also using the project dashboard to keep track of what we're doing. We have created the repo, and we have an implementation, basic implementation of the encoder, mock encoder. Tomorrow, as I have said a couple of minutes ago, we're going to start 3 hours later, and there we're going to refine this idea. So this another thing that needs to be well understood. When you are working with an issue, you're creating a branch. The branch may need multiple commits, even multiple changes that undo, redo things, etc., until you are happy with that new feature. Obviously, at the moment, I am not happy with the feature because we don't have any error management. and we don't have a trait. So those are the two things that we're going to code tomorrow. But at the moment, tests work. Also, let me where is the main file? So as you can see, because we have created the documentation, this is what it has been created for us. So because everything is in the library, not in a proper module, which is yet another thing that we need to do tomorrow, we don't have a typical blurb for the module. It's just directly the crate. But you know what? We should have a blurb for the crate. At least it should have hello. It should have the short description. Okay, perfect. And now we have our symbol with the comments, the variants, and things that are implemented. So debug partial equality and structural partial equality, which I didn't know that was a thing, but here we are. And then for the encoder, all things that we have done, some auto traits, etc. Right, then as you can see, all of that has been created with the documentation. I'm very happy with what we have achieved today. Again, tomorrow there are 3 things that we need to add. So I'm going to go here in the description. Can I edit? Can I edit? So basic encoder with test and docs. Okay, what else do we need to do? First we're going to have the trait, then we're going to have error management, and tomorrow you will see why they are in that order, and lastly a module. Okay, so we have already done the first thing. Happy. And with that being said, thank you very much for attending the stream today. Before I go, yes, I am working still with compression, but I just came back from holidays. There are many things that are in the pipeline. Streams with other projects. This is something that is already in in the Twitch description box. I want to work with other mechanisms, other technologies. I want to do things related with assembly and networking. And when I set up the YouTube channel, if everything goes fine, in time when I start learning about video editing, I will be starting to publish videos in YouTube related to what we did in the past here in Twitch. So learning basic things about Rust in terms of data types, enumerations, result data types, vectors, error management, memory ownership, etc. Basically becoming a Rust programming channel in YouTube, but that will be over time, obviously, if those things have good reception. And yes, I think that's going to be my last words for the day. So thank you one last time for joining me today or watching in YouTube the video, and I see you in the next one.